Compiler, in the context of Python, can be a bit confusing because Python is typically considered an interpreted language. However, there are several nuances to understand. 1. Traditional compilers versus Python interpreters. Traditional compilers. In most programming languages, a compiler directly translates human-readable source code into machine code understandable by the computer. This compiled code runs faster and doesn't need an interpreter each time. Python interpreters. Python primarily uses an interpreter. This program reads and executes your code line by line, making it great for rapid prototyping and development. However, it sacrifices some performance compared to compiled languages. 2. Bytecode as an intermediate step. Python bytecode. While Python isn't directly compiled to machine code, it's first translated into an intermediate representation called bytecode. This bytecode is platform independent, meaning it can run on different operating systems with a Python interpreter available. Just-in-time, JIT, compilation. Some Python interpreters utilize JIT compilation, which further translates bytecode into machine code for specific functions on the fly. This helps improve performance without sacrificing the flexibility of an interpreter. 3. True Python compilers. Specialized compilers. While uncommon, some tools like Cython, Tkinter, and Shedskin act as true Python compilers. They translate Python code into executable programs for specific platforms like Windows or macOS. These can offer significant performance gains but require more complexity and platform-specific considerations. Therefore, compiler, in Python, can refer to the interpreter itself. For basic understanding, you can think of the interpreter as a compiler that translates bytecode on the fly. JIT compilation within the interpreter. This improves performance by dynamically creating efficient machine code for specific functions. Specialized third-party compilers. These create standalone executables for specific platforms, sacrificing flexibility for performance. In summary, although Python lacks traditional compilers like C, C++, its interpreter uses bytecode and JIT compilation for a balance between development speed and efficiency. Specialized compilers exist for specific needs, but the core Python workflow revolves around interpretation and bytecode execution. I hope this clarifies the concept of compiler in the context of Python. Feel free to ask any further questions you might have.